Alright, we're going to try to go through this Unit 7 quest review as quickly as possible. I know it's 30 questions, and you're probably watching this at about 9 o'clock, but we'll try to do as best as we can to get through this, to get you prepared for the quest tomorrow. Remember, it's open notes, so hopefully you did the review and you can use this and you'll be good for tomorrow. Alright, so the first one, the length, width, and height of a rectangular prism are multiplied by 2. Describe the effect that this has on the volume of the rectangular prism. So let's just say we have numbers, let's say 3 times 2 times 4. If I'm multiplying each one of these by 2, that means it's 2 times 2 times 2, which is 2 to the power of 3, which is 8. So if each one of my length, width, and height are being multiplied by 2, the effect this is going to have on my rectangular prism is that this is going to be multiplying it 8 times. So it is going to be 8 times the volume. All right, number 2, it says Mr. K studies and he has a survey, and one sample size has 10, the other one has 150. They came back with different results, with different means, standard deviations, and margins of error. Why are these two surveys having such different results? That is strictly or mainly due to the sample size. So, because one sample size is 15 times larger than the other, the larger the sample size, the more accurate the results are going to be because it's more representative of our population. So, an explanation would be the larger the sample size, the smaller the margin of error. Okay, that's just the main thing there. That's how it affects those two. All right, the next one, a company estimates taking a simple random sample of 50 students. For each sample student, we have these laptop costs. And then it says 95% confidence interval. We have a margin error of 100, and the laptop standard deviation is 361. And then it's saying how large of a sample will make the margin of error $50. So as we see, the margin of error is decreasing from 100 to 50. It's cutting in half. So if it's cutting in half, that means the population is going to be 4 times the original size. So that means 4 times 50 would be 200 students. That would be the actual answer. Now, if you wanted, I'm not really going to go in depth on this whole entire thing here. Now, technically, because we're trying to divide by 2, the square root of 2, or the square root of what is equal to 2, that is 4. So 4 times 50 would give me 200. That's how I can think about it like that. If you cannot conceptually understand that whole entire process there, you can always just solve backwards with a calculator, because it says your margin of error is going to be 50. That will be equal to your z-score of 1.96 times your standard deviation of 361 divided by the square root of n. All you have to do in this one is just solve backwards and figure out what n is going to be, and then you'll have your answer. Alright, moving on. We have the online poll, and it says that 65% of the people that were polled are in favor of getting rid of daylight savings time. And now it's asking about the true unknown percent, though, who are in favor of eliminating daylight savings time. This is representing the whole entire population of the United States. We don't know what that is, but that percentage, because it represents the whole population, would be our parameter. I know this can be kind of tricky because you see at 65%, you're going to say, man, that's a statistic. No, because it's asking about the true unknown percent of American citizens. That's talking about the actual population and that percentage. So that means it will pertain to our population, which means therefore it's going to be our parameter. All right, moving on, we have this asking about ice cream flavor, 9th grade students, and Sanjita's asking her 5 best friends in her 9th grade math class what their favorite are, and it's saying what method represents a given scenario, and it's not convenience, because it could be convenient because of the fact that these are her 5 friends. Let's just ask those 5 people. This one is actually going to be clustering. Now, I'm not a huge fan of this question itself, but I guess the best way we can think of this is that the cluster is going to be groups of people in the math class, and she's asking all 5 of those friends, so therefore it's going to be a cluster then. Anyways, moving on. We have a hemisphere, and it's asking how can I obtain a semicircle from a cross section. So that would mean we have this half sphere here, and then how can I cut this to get a semicircle? We would have to cut it perpendicular to its base, so that would be like here. And the way I best described about this was, imagine you have a watermelon, a circular watermelon, it's cut in half. If I was to cut it parallel to that bottom side of that half watermelon, I'm just going to get circular slices. I don't want those. I would cut it perpendicularly up and down, and then I would get semicircles. And then how many times can I cut this to get a semicircle? I can technically cut this infinitely many times to get the semicircle. So it would be perpendicular, and then how many times? It would be infinite. All right. Number 7, we have a 95% confidence interval, and we want it to be more precise. What 2 things can I do to narrow my confidence interval? We talked about this earlier. The first one would be to increase the population, because again, the greater the population, the more accurate the results are going to be. And then also, if I want to make this narrower, I can also decrease the confidence level. Because if I decrease my confidence level, think about it as a target. A 95% confidence interval, sure, we know that's like our baseline. If I was to have a 90% confidence interval, that means my target's going to get smaller, which means I have a lot smaller region to get. Whereas if I had a larger, like a 99% confidence interval, my target would be a lot bigger. I'd be more confident hitting a bigger target. So we can take down our confidence level. We can also increase our population. All right, study conducted. We have 134 of 850 students with at least 1 pet, and it wants us to find our sample proportion and our margin of error. So to get our sample proportion here, that would be my p hat. That's going to be equal to 134 divided by 850. And that would give me, I'm just going to round to my nearest 100th place, 0.16. Then I would go ahead and I plug this into my formula. So my margin of error, that's going to be equal to 1.96 times the whole entire square root of 0.16 times 0.84. Again, that's 1 minus my sample proportion divided by my entire population, which is 850. I don't have a key on me, so I can't just easily look at this. So let's say I do 0.16 times 0.84, and then I divide that by 850. I take the square root of that, and then I multiply that by 1.96, and I should get about 0.025. All right, so this would be my margin of error right here, and this would be my sample proportion. All right, next question. Is the following statement true or false? Explain. So unless we have sampled the entire population, we cannot know the exact mean of the population. This would be true, because in order to get the true mean of the population, the exact true mean of the population, we need everybody, because population is the whole entire demographic which you're trying to encompass here. So true, we would need everyone. Not just a sample of it, we would need everyone. Okay. It wants us to conduct a confidence interval here. Again, I don't have a calculator on me right now, so I'm actually just going to set this up. You can go ahead and solve this yourself. We have a simple random sample of 50 adults, a mean income of that, a standard deviation of 397. So we would do 1.96, and that would be multiplied by 397 divided by the square root of our population, which is 50. Whatever I get here, let's say that's going to be our ME. Okay? Then we take our ME and we do 52100 plus and minus our margin of error, and that will give us our confidence interval. Again, calculate that on your own time. I'm just showing you how to set it up. Next, it says when taking a simple random sample of population and calculating a statistic, the statistic can be used to draw inference about what? We do this whole entire sampling of a population to create a statistic, and then we use that statistic to make an inference about our whole entire population. Okay? So because it's really hard to go ahead and survey an entire population, kind of like we said in number 9. So therefore, we do these random samples and then take a statistic from that and then interpret that to go ahead and represent our entire population. Number 12 is a lot like number 3, I believe. If a sample size used to calculate a confidence interval is divided by 4 and everything else remains the same, what happens to the margin of error? Try this with some random numbers. You should be able to figure out. It's going to multiply by 2. Okay, so your margin of error will multiply by 2. All right, if I was to draw a cylinder and take cross sections parallel to the base, so let's say I have a cylinder like this right here, I'm taking cross sections that are parallel. So like here and right here. What am I going to get for each one of these cross sections? That is going to be congruent circles, because again, all of these circles are going to be the same. It's just going to be horizontally cut across. How does my confidence interval change as my confidence level increases? Again, think about like the target. My confidence level, my target's getting bigger, so therefore my space that I can hit on my target is getting bigger, so that means my confidence interval is going to get wider. All right, this one here. It says I have a cylinder, base area of 169 pi inches squared, and the height is equal to the radius. So that means the radius is going to be equal to 13, because base area for a circle is pi r squared. Divide that by pi and then take the square root of that. I'll get 13. Square root of 169 is 13. So to get my volume in terms of pi, I'd be 169 times 13. That would give me 2197 pi. So again, I get that by doing 13 times 169 pi. That gives me my volume. If you want to get it into round to the nearest tenth, you multiply that by pi. That will give you about 6902.1 because it's asking for the nearest tenth. And that would be in inches cubed. Number 16, when making a statistical study, we should not have any bias in order to get the most accurate results. Great. In center here, that means this, and this are all going to be congruent. So that means 3x plus 14 will equal 9x minus 34. So I'll have 6x is equal to 14 plus 36, which is, not 36. 14 plus 34, which is 48. So 48 divided by 6 is 8. So 8 equals x. I just go ahead and plug this back into either one of these because, again, it's going to be the same. 3 times 4 is going to be 24. 24 plus 14 is going to give me 38. So that means MP will equal 38. All right, moving on. Panera Bread, it's conducting a survey. Here we have 65% of the people said that they like, or their most important factor is how fast the food is served. So based on the result, UNC Panera franchise can infer that customers at the UNC location prioritize fast service. All right. Max wants to predict the results of the next student body election. He chooses random sterile at school and surveys every 5th person that walks by. Identify the population and sample and give a reason why the population can be biased. So the population, because he's going to figure out the student body election, all the students at the school would be the student body. And then the sample would be every 5th student at the stairwell. Now, give the reason why the population can be biased. I'm not going to write this down because I don't feel like writing anymore for this question at least. Let's say the one stairwell that he's standing by, only seniors walk by it. So he might only be getting the opinion of every 5th senior. So that could potentially skew our results. All right. Next question. Interpret a confidence interval for its given context. So we have a gym class, vertical jump. They take 45 people. And they conducted a confidence interval and 95% confident from the ranges of 12 to 25 inches. So what does this mean? This means that we are 95% confident that the interval of 12 to 25 inches represents the true mean vertical jump of students in Panther Creek gym classes. All right. Again, we've done questions like that, writing our whole entire statement. Moving on. We have a centroid. RS, this here, is equal to 15. RY, which is here, is 4. And then RT, which is this whole entire segment here, is equal to ST. Because it's a centroid, this part is going to be equal to this, so that's 4. So that means this is 8, and this is 8 as well. So if I go ahead and add all of my sides together, I will have 8 plus 8 plus 15. So that means the perimeter is going to be equal to 31. All right. Moving on. Right triangle, 4 and 7. So 4 and 7, it's rotating around the smaller leg. So that means I will have a cone, and it's going to have a height of 4, and my radius is going to be 7. So that means it's going to be pi times r squared, which is 7 squared, times our height, which is 4, and then all of that's going to be divided by 3. You can go ahead and calculate that. I'm not going to calculate that because, again, I've been writing, and I'm trying to get through this as quickly as possible. This one here, again, actually, not this one here. This one says that a poll was conducted on constructing a new park in Cary. 182 of the 286 voters said they would be in favor of a new park. And that would mean, does this mean that 63% of the residents are in favor of the new park? Explain our answer. So they just took our sample of 182 divided by 286 to get that 63%. Does that represent that all the residents, or 63% of residents in Cary, are in favor of the new park? No. That's because the sample statistic does not represent the whole population, which is Cary residents. Okay. Now, if they made a confidence interval and we're like, we are 95% confident that X number, or that the interval of 40 or 54 to 68% of Cary residents are in favor of a new park, sure, that could potentially work. But because it's just talking about taking our sample and saying our sample proportion is what our statistic is and that represents everybody, no, that's just that's just sample proportion. That doesn't represent everybody. The researchers dividing sample into 2 groups. One a control group. The control group is the key word here. That means this is going to be an experiment. All right, group of golfers. standard deviation of 9, a mean of 83. Again, so that means whenever we get our margin of error, it's going to be 83 plus or minus our margin of error. I'm setting this up again. Go ahead and figure it out on your own after I set it up. So that means I will have 1.96 times my standard deviation of 9 divided by the square root of 64, because that's our population. That's going to equal our margin of error. And again, add and subtract that from our mean, and then it will give you our confidence interval. This one right here, hospital has patients, they're grouped by the type of treatment they're getting, and then a random 50% of each group is being selected. Because they're first off broken into groups, and then those groups are randomly sampled after that, that is going to be stratified. What will increase the confidence interval of a population mean when the mean, standard deviation, and sample size remain the same? That will be an increase in the confidence level. We talked about this earlier. If everything else is the same, the only thing we can change is the confidence level. We go ahead, we're more confident. That means our target's going to get bigger, so that means our range will get bigger for where we can hit our target. Why are these last two questions not showing up? There they are. Rectangle, length of 6, width of 3. So let's say, and it's rotated around the width. So that means 3 here, and then a 6 and a 6 here. That's going to be my cylinder. So that means that will be pi r squared. My radius is 6 times my height, which is 3. Calculate that, figure it out. Again, sampling distribution is a statistic. The sampling distribution of a statistic is, I'm just going to pick these. This one is going to be B. It's a distribution of values taken by a statistic in all possible samples of the same sample size from the same population. Again, evenly distributing there. And then the last one, a company advertises only 1 in every 50 items has something wrong with it, and a consumer group buys 1 item at random and it works perfectly. What can be concluded? We can just conclude that the group did not choose a large enough sample size to reach a conclusion. Picking 1 does not represent everything. Great. All right. I hope this helps. For those who need to review our quest review, again, it's open notes, so make sure you have all your materials that you need. Utilize those. Open notes does not mean open computer. Don't even think about that. Yeah. Again, any last questions about this or need any other explanation, feel free to email me. And good luck tomorrow. It's your last test of the year. I'm sure you're going to do fine. You guys are all smart. And then we're going to crush it on our end of year test. All right.